Hi, I'm Ray Milkey. I work at ONF. I'm one of the core developers on ONOS. I'm going to talk today about Bazel, which is a build tool that we put in starting with the 1.14 release. So the first question people will ask us is, well, why did we ditch Buck? Buck was a big upgrade for us from Maven. We used it for a few years, but we ran into some problems. Builds are often unreproducible, particularly between our Macs that developers used and the Linux boxes that we used for sort of deployments. The extension model was very limited. We were forced to actually write code that was inserted into the tool, rebuild the tool, publish the tool. It was sort of a pain. We were stuck on a custom fork because of putting in this custom Java code. What this meant was, as Buck development went on, we were kind of stuck unless we wanted to merge back, which we did a few times. It got very expensive. It got very hard to maintain. As I said, we required custom Java code to do things like, for example, we generate OSGI bundles directly out of our build system. You can't do that with the stock Buck. We had to actually write Java code to do that. No support for remote repositories. We'll get into that a little bit more. That's a very sort of Bazel-ish thing, which we're finding is very nice for source code disaggregation. And the community was kind of quiet on Buck. There were only a few people using it. It was mostly used by Facebook, not used by a lot of other companies, and there wasn't a lot of sort of progress being done on the tool. Okay, so why did we choose Bazel? There's a lot of different tools out there. The fundamental thing that Bazel attempts to do is what they call hermetic builds. A hermetic build is essentially, think of an egg with the yolk inside. That's hermetic, nothing can get inside. The idea behind hermetic build is nothing on the host that you build on gets in there unless the tool knows about it. And the way they do that is through this notion of sandboxing, where they basically don't allow anything that you don't explicitly say you're going to use to be in that whatever artifact you produce. This means that, for example, if I do a build on my local macOS laptop, the bits will come out almost exactly the same as modulo timestamps as they do on our build machine, which is running Linux. Built-in support for external repositories, like a lot of the stuff that Carmela was just talking about with P4, we see this with Protalk. There's a lot of sort of these tools that we use that we had to integrate into Buck. The way that Bazel works is people who work on those tools publish their own Bazel rules and we can just use them. We don't have to actually mess with them at all. It's a very active community for Bazel. It's mostly coming out of Google and there's a sort of community being built around that. You're starting to see it in some other open source projects and they're doing like 3 to 4 week cadences on their build. So they're really doing a lot of good work. The rule model in Bazel is really flexible. So when you specify a rule and you say, here are my inputs and here are my outputs, all that information is now available directly in the Python code that you run. That was not true with Buck. Buck filtered out a lot of the things, and so we really couldn't make good decisions a lot of times without digging into the guts of Buck. Multi-language support. So for example, I use rules currently when someone builds ONOS that are written in Go. I don't care. All I do is I reference their repository, it downloads the compiler, it builds the compiler, it builds the rules. I don't have to worry about it as long as their rules are up to date with the same version of Bazel I'm using. Currently within ONOS, we have Java, Go, C, and C++ code that's being built, and most people don't even know it's there because Bazel just takes care of it. And also just internally within ONF, Stratum, in their partnership with Google, is going all out on Bazel, and it just made a lot of sense for us in ONOS to be using the same kinds of technology, just so as things converge, it becomes much easier. Okay, we'll talk a little bit more about hermetic builds. So again, think of the egg and the yolk. The build should be reproducible across all platforms. You should not have these problems where someone's building on a PC and I'm building on a Mac and we get different bits out. That's a very important thing to do when you're trying to help somebody debug something. The host environment should not be able to pollute the artifacts. So you shouldn't, for example, if I'm using a certain version of Java, you're using a certain version of Java, that should not be a problem. The tool should make sure that the version of Java we say we're using is the one that's actually being executed. This notion of sandboxing is implemented on Linux and on Mac OS. It's a very strong reason to use the tool. because what it's doing is it's basically saying only the files and only the data that you tell the tool you're going to be dependent on are you allowed to use. And the way it does this is through this very intricate thing of creating symlinks and all this other stuff. Most of the time, unless you're writing your own rules, you don't have to worry about it. But the good thing is that what it's doing is it's basically saying that, hey, you didn't tell me this data file was part of your artifact. When that rule is done, the artifact is gone. So that's one of the ways that they're making sure that my builds are the same as yours. Hermetic artifacts can be cached and shared. We don't really take full advantage of this yet. You take advantage of it locally when you do iterative builds. You'll see things like the core API will only get built once because there's nothing that it depends on that's changed. You can take that one step further if you allow, for example, those artifacts to be uploaded somewhere. I can make a change to core net, check that in. You can pull that change, but you won't have to build it because it'll already be there. And that's one of the things we want to investigate going forward. And you'll see a lot less churn on rebuilds. So the initial Buck build was faster than the initial Bazel build is, but subsequent builds are considerably faster using Bazel. References to external repos. So this is very important for source code disaggregation. So for example, now if you want to write your own application and use Maven as your build tool, well, we publish things up to Maven Central, and then you have to depend on them and download them, and there's just all these intermediaries involved. The way that Bazel works is it's explicit. You say, here's a URL. Oftentimes it's like a GitHub repo. I depend on this. There's a build file in there. Bam, it just works. They had this notion of workspaces, and workspaces carry a set of data to work on, which could be source files, it could be resources, it could be all kinds of things, and then the build rules to build them. There's also another thing that we use, which is this injection model. So say I'm using somebody's library that I really like, but they're building with Maven. What I can do is, and we actually do this in ONOS currently, is I can write Bazel rules to build their code that's checked into my tree, but I'm still referring to the code coming out of the repository. So this has the advantage of whatever work they're doing, I get to take advantage of, but I don't have to deal with their Maven stuff. I can build it directly as part of ONOS using Bazel. GitHub repos are supported out of the box, and the way this works is there's a special URL based on the identifiers for your GitHub repo that will download a zip file, and they basically have rules wrapped around that will unpack it. So it looks to you as if that GitHub repo is on your machine. You don't have to mess with any of this, Git checkouts and that kind of thing. It just does it for you. We're currently using this for protobufs and for NPM, like protobufs, for example. We actually download the compiler. We build the compiler using C rules, and then the protocol compiler runs on the models to produce the stuff that ONOS uses. Carmelo touched on this a little bit. We would love to use this for P4 builds. We're not doing that right now. We have kind of a manual step in between just because we haven't done the work to bridge the two of them together. Flexible rules. So we, in ONOS, because we're using OSGI, because we're using P4, we use a lot of different technologies, right? So any build tool we pick is probably not going to support everything we need, so you always have to write plugins. The way that works in Bazel is they use what they call Starlark, which used to be called Skylark. Skylark's a much easier name to pronounce. I don't know why they changed it. But basically, it's a subset of Python. So think of it as Python without all the host-dependent stuff taken out. So you can't open files, you can't create things, you can't open pipes. But the syntax is something we all know, and it's very easy to deal with. To maintain the hermeticity of a rule, you have to specify all the inputs and outputs. But when your Starlark code runs, you have access to all of that. So there's none of this stuff we had to do with Buck where you look things up through 5 different intermediaries. It's all right there. Inputs and outputs have to be declared, same as any other rule. And currently, if you take a look in the tools build Bazel section of the ONOS tree, you'll see the ones that we've written ourselves. OSGI obviously is one that's really important because we use Carafe as kind of our base deployment model. But we do things like Swagger, building Yang models, building ONOS apps. These are all written as code that's checked into our tree. And if you ever want to look at how they work, you can just take a look at that. So what we have left to do with Bazel. Right now, the ONOS app archetypes, I don't know if any of you have written your own apps, is very tied into the Maven model. We'd really like to have a model based on Bazel. Sonar, currently we don't have code coverage coming out of Bazel. We have the static analysis portion of it, but we don't have the coverage part of it. That's something that I've been working on off and on. It just need to sit down and get it done, basically. We'd really love to, first internally and then maybe even publicly, have some kind of a web-based cache so that people can share each other's work rather than having to download, rather than having to build everything again. You can just do it as a direct download. For us, on our Jenkins box, if any of you check in code, you know it takes like 15 to 20 minutes for the verify job to finish. If we had that third bullet point, those would be like lightning, because only the files you changed would ever have to be rebuilt. And there's a notion also in Bazel, which I find very kind of interesting, of a remote build capability. So you can, for example, have all the code locally, but have a build server that you use. So this would be really nice, for example, if you have some kind of a cloud-based system where you can sort of do your builds off-world. You don't have to actually do them locally. Because one of the problems we have with Bazel is that it is very much of a resource hog. It uses a lot of memory, it uses a lot of CPU. If you had big beefy like build servers, you might be able to offload some of that information. And that's what I have to talk about Bazel. Anyone have any questions? Yeah, John, who knows Bazel as well as I do.
Yeah, thanks. So recently we noticed that, so now since we are moving from Craft 3.x to 4.2.1.1, so one of the enhancements if we move to that version is we can use Java 11, right? Mm-hmm. But as far as I know, the ONF codebase cannot be built against Java 11. It's still just built up to Java 9, as far as I know. So I would like to know what does ONF has a plan to support that type of like direction? For example, like build 11. So second thing. So still ONF using Oracle JDK, and as you know, they're gonna charge for. I mean, maybe next year. I'm not quite sure, but I'm not sure. Is that possible to build ONF against OpenJDK so that we can still using ONF without paying anything?
So, okay, so it's interesting that you said that, because I was actually just working on this while waiting for this meeting. Thomas is smirking at me. So there's a lot of bits and pieces. So to get into kind of the gory details, there's 4 JDKs actually that matter to Bazel. There's the one you run Bazel with, there's the one you compile with, there's the one you run programs with, and then there's a remote one. We don't currently use remote, so we can leave that off. Right now, Bazel ships with its own version of a version 9 Open JDK. That's also what you're building against. Even though you have whatever Oracle version installed on your machine, it's building with its own internal Java 9. The Bazel people are working on getting that upgraded to 11. What I did before this meeting, which was actually pretty cool, there's a 0.20 version that just came out of Bazel, and I was able to actually run the Carafe image against my installed 111 JDK. So in theory, what that means is it's built with the 1.9 that's part of the tool. It runs with whatever your local JDK is, and Oracle is cut out of the picture. So we're still trying to figure out kind of how to tell people how to do this the best way. There are a few changes that have to be made. When they finally do go internally from 9 to 11, we'll have to make some source code changes, because there are some of the Java X packages have been split up, moved around. It's not source code compatible. So it's on the roadmap. We really wanted to do it for this 2.0. I don't know if we're going to have the support in Bazel to do it. So maybe we'll end up doing a 2.0.1 or a 2.1 or something that supports 111. But we definitely want to get off 1.8. We know that's a problem. I think for the version that we release in 2 weeks, so whenever we actually do the official build, we'll support running with 111. I think that's pretty guaranteed.
And one last question.
Sure.
Is, so ONF sort of like supporting a Docker like a container image, so that the output of ONF's like a build will be eventually be Docker image. But by far, we are using the Alpine Linux as a base image, mm-hmm. and then ONF's and then it embedded with the JVM like a server mode plus ONF. But as far as I know, from the Java 9 or maybe Java 10, this Alpine Linux like image doesn't work properly because they do not have the proper library support for that version. So in that case, we have to fall back to the Ubuntu or some other like Linux distribution. Then the image size is going to be increased a lot. So my question is, so what type of like a workaround that ONF are currently considering to reduce the image size, even if we move to the upper version of Java?
Okay, so I'll be frank with you. The Docker stuff, the person who worked on that has left ONF. So we're kind of, stuck trying to figure out how that stuff works. I think right now what it does is, I think as you were saying, it starts with a base Ubuntu image. It installs a 1H JDK, and then it does the build on top of it. Obviously, moving forward, since 1.8 is end of life, and potentially Oracle will start charging a tax on things, we're going to move away from that. But I can't give you specifics about when we would do it. It's just something that's on the roadmap. It's something we have to do, but I just don't know where the resources to do it. If you know how to do it, I know you were very good at doing nice check-ins, so maybe you can work on it, or you know somebody who can. That's the beauty of open source, is anytime anyone asks you for a new feature, you can always say, well, you can implement it. Anyway, anyone have any other questions about Bazel builds, anything related to this presentation? I don't see anybody. All right, well, thank you.